Okay, good morning, afternoon, or evening, everybody. Welcome to the Discover and Access Earth Science Data using Earthdata Search webinar. This is your host, Jennifer Brennan. It is 2 p.m. Eastern Standard Time, so we are going to go ahead and get started here. And what I will do first is begin today's webinar with just a few logistics. To ensure the best audio experience, all participants have been placed in silent mode. But if you have any questions or you have any issues, what I'd like for you to do is enter those into the Q&A panel rather than the chat. And you should see this located in the panel on the right side of your screen. And if you don't, there are three dots of your screen. And if you select that, you'll have an option to add panels. Okay, today's webinar is being recorded. The recording will be posted both to the NASA Earthdata website as well as to our NASA Earthdata YouTube channel within a couple of days of completion. And then once completed, what I will do is I'll send an email to all registrants with the recording links as well as a link to the presentation slide deck used within today's webinar. As far as timing is, today's webinar will be 1 hour long with 45 minutes allocated to the presentation and demonstrations. A 15-minute Q&A period will follow, and depending on the volume of questions we receive, we may extend the Q&A session an additional 15 minutes from end time, but we will have a hard cutoff of 3:15 p.m. Eastern. Excuse me. During today's webinar, we will have one speaker and 3 Q&A session panelists. Our speaker this afternoon is Alicia. She is the product owner for Earthdata Search. Let me actually pull up the agenda here as we go through this. Okay, she will begin today's webinar by providing an introduction to NASA Earthdata and take you on a brief tour of the Earthdata website. She'll highlight paths for getting to Earthdata Search from Earthdata and also point to learning resources that can help you with your data product selection. From there, Alicia will provide an introduction to Earthdata Search and conduct a live demonstration where she will show you how to search for data, preview the data, and also access and download data sets. Once our speaker has finished with her presentation and live demonstration, we will transition to our final optional polls and then jump directly into the Q&A session. Today's demonstration, excuse me, I've already covered the live demo. Okay, so our Q&A panelists for the end of our today are Valerie Dixon. Valerie is the NASA EOSDIS Search and Discovery Lead at Goddard Space Flight Center. Joe Roncione is the Product Manager, and he'll also be joining us during the Q&A for the Search and Discovery Train on EED, and also Ryan Abbott, who is the Systems Architect for the Search and Discovery Train on EED. And just a final note about the Q&A. We'll try to answer all the questions within the time allotted, but if we are not able to your question during the Q&A period, we will follow up with you offline. With that, I am going to stop sharing my screen here and toss it over to our speaker this afternoon, Alicia Ullman. Give me just one moment. All right, Alicia. At this point, you should have presenter mode.
All right, let's give this a try. Share my screen. All right, tell me you can see my screen.
I can, thank you.
Okay, great.
Perfect.
Awesome. Well, hello, hi everyone. Good afternoon. I'm Alicia. I am the product owner for Earthdata Search. Let's do just a quick recap of the agenda for today. The first part of the presentation will be a brief introduction to NASA Earth Science data. I'll walk through some of the available resources to show you how to learn about and identify data of interest. Reviewing those resources first will, I think, provide some helpful context to the second part of the presentation, where I'll talk about Earthdata Search, what it is and how it can be used to find and access data of interest. And then we'll finish with the Q&A. All right. So starting at a very high level, and this is quite literally the satellite view, these are all of the current and future satellite missions in NASA's Earth fleet. Each of these satellites has multiple instruments and sensors taking measurements of Earth and sending it all back to NASA data centers for archival and distribution. These instruments and sensors are gathering a lot of data about Earth, We're talking hundreds of petabytes of data, and that number is growing and growing very fast. And while that's great and amazing, it also presents a challenge for our users, especially new users, who want to find and access this data for use in their research, but aren't familiar with what's out there and need help getting started. NASA's Earthdata website is a great resource for learning about our data offerings. Through the website, you can learn about the different types of data available across 9 science disciplines, access information about available data products, as well as related services and tools, find links to learning resources, including data recipes, tutorials, and examples of how the data are being used in research today. So let's quick little detour here over to the Earthdata website. Let me actually get out of this other window here. Okay. All right, so I'm going to walk through the content just a little bit, just really highlight the content that I think is most helpful to new users. So Earthdata organizes NASA's Earth science data offerings into 9 high-level topics, which are atmosphere, biosphere, cryosphere, human dimensions, land surface, ocean, solid Earth, sun-Earth interactions, and the terrestrial hydrosphere. Selecting one of the topic icons will take us to a content-specific page where we can learn about the different types of data available for that topic. And as an example, we'll just take a look at cryosphere. And on the topic page, you'll see a high-level description of what cryospheric data is, and some examples of the data products that provide information about, in this case, the frozen parts of Earth, such as ice thickness, glacial extent, and glacial mass. As you scroll down the page, you can also access information about the different data archive centers responsible for the management of these data. And then below that, there are some subtopics that you can click on. Let's do snow and ice here. To learn about specific types of cryospheric data that are actually cataloged. There are also a number of links and references to related articles, news items, and programs about cryospheric data. So the last thing I want to point out on this page, as kind of a sneak peek to what's to come later in the presentation, is that you can also go directly to Earthdata Search from these topic pages by clicking the green Find Data button at the top. And you can see that when the page loads, it's been pre-filtered for cryospheric data just to help get you started. All right, so we're not going to get into the demo just yet, but I wanted to point out this one entry point into Earthdata Search. So I'm going to go back over to Earthdata. The next resource I want to highlight is Data Pathfinders. To find this resource, you hover over the Learn menu item at the top of the page and then select Data Finders from the list. Data Pathfinders contain resources that guide users through the process of actually selecting and using data sets applicable to a specific environmental issue. There are 9 Data Pathfinders to choose from: air quality, agriculture and water management, biological diversity and ecological conservation, disasters, diseases, geographic information systems, greenhouse gases, sea level change, and water quality. And then just as one example, let's take a look at, I'm going to choose sea level change. There's a lot of information on this page, so I'm just going to break it down just a little bit. At the top, you'll get an overview of what sea level change is, how it's studied, and its effects on the planet. Below that, scroll down here, you'll see a list of common measurements used to study sea level change. And this table details just some of the attributes associated with these measurements. For example, if you're interested in data about changes in ice mass, you can see which satellites and sensors collect these data. And then as we continue down the page, you'll find, gotta scroll down kind of far. You'll find links to the most commonly used data sets for this particular Pathfinder, as well as information about how to use the data. The last resource I want to highlight is the Earthdata Forum, and you can find a link to the forum actually on the Data Pathfinder page right here. I'm going to click on this, take us over to the Earthdata Forum. And the Earthdata Forum allows users to interact directly with subject matter experts at NASA's data centers, as well as the broader scientific community. Provides the opportunity to discuss research needs and get answers to specific questions about using NASA Earth observation data. You can post new questions by selecting Post a New Question button right over here. And you can also search the forum archives by selecting the Quick Links menu up here at the top and selecting Search. And you can see there are, looks like there's over 4,000 topics that have already been posted here. And so you can use this search interface to search through those. That was a very brief, probably the briefest of brief introductions to some of the NASA Earth data resources that are available to you. I know we just kind of scratched the surface of what's out there, but I encourage all of you, especially all of you new users out there, to take advantage of these resources to learn about all of our offerings. All right, hop back over to the slides. Okay, so now for the rest of the presentation, we're going to assume that you know the type of data that you're interested in. You know what you're after, but now you're faced with a new and possibly even more daunting task or challenge, and that's how do you begin to sift through the tens of thousands of Earth science data sets to find your data of interest? Well, Earthdata Search is the tool that's going to help you tackle that challenge, and I'm going to show you how to do exactly that today. So what is Earthdata Search? Simply put, Earthdata Search is your one-stop shop for finding and accessing Earth science data. It allows you to search more than 1 billion individual data files all in one place and makes it possible to get the data you're interested in and only that data quickly and easily. It provides access to Earth observation data sets from NASA EOSDIS, as well as US and international agencies across the Earth science disciplines. And it seeks to ease the technical burden on data users by providing a tool that makes it simple to search for data by date and spatial area. You can preview sample imagery and also access data through a fairly streamlined download process. One final but important note that I want to get out of the way before I jump over to the demo. An Earthdata login account is required to download and access data using Earthdata Search. It's something that's required by NASA, but setting up an account is free and easy to do. And if you don't already have an account, you can head on over to this URL to sign up today. Okay, so let's head on over to Earthdata Search, and we'll start the demo of some of the core features and functionalities. And let me start by saying, start this section by saying that I'm not going to be able to demo or cover everything that I want to today, but that's okay. I promise that you'll walk away with more than enough knowledge of the tool that you started and on your way to using Earthdata Search. Okay, so now that we got that out of the way, so shoot, I forgot to log out. So the first thing I'm going to do when I reach the site is log in or make sure I am logged in. If I was not, actually, let me just log out, and then that way you can see this. Okay, so first thing I'm going to do when I reach the site is log in, and I do that by selecting the login button in the top right-hand corner of the page. And I've already, usually it would ask me to enter my credentials, but I'm logged in another application, so it knows who I am already. So I'm logged in now, and I know that I'm logged in. I can see my name displayed up in this upper right-hand corner. So quick lay of the land. The application has three main parts to it. The panel on this left-hand side of the screen is where our search criteria. The center panel is where the application displays data sets matching the search criteria that was entered in the search panel. And then the right panel is a map that can be used to do your spatial search and also visualize data or visualize map imagery associated with some of these data sets. So there are a couple different ways we can actually start a search on the site. For today's demo, I'm going to show you the primary path users take to find data. And to do that, we're going to follow a use case that's going to set a scientific context for us to follow. So most searches are made up of three main components: a keyword or term, the date, time range, and the spatial area of interest. So our use case is going to be grounded in those three components. I know here. So full disclosure, I'm not a scientist. So this use case did not come from an actual research study of mine, but it does provide the appropriate context we need to learn how to find data. So I live in Colorado in the high country, and I'm very interested in the amount of snow this region of the US Rocky Mountains gets on an annual basis and how that's changing over time. So for our use case, we're going to be looking for data related to annual changes in snow cover in the Central Rocky Mountain region of the United States for, let's say, the last 5 to 10 years. So I'm going to start my search by typing a term into the search box. The search box is in the upper left corner of the tool here. Now you can enter any term you want here. Could be a science parameter, the name of a satellite or instrument if you know it, or even the dataset ID if you happen to have it. So I'm looking for snow cover data. So I'm going to enter in the term snow cover and hit enter. And it's going to return a list of matching collections. So it looks like there are just under 700 matching collections to that term. I'm going to pause here for a minute and point out the autocomplete feature. So you may have noticed that when I started to type in this term in the search box, in fact, after I typed in the first 3 letters, the tool started to process what I was entering. So what's happening behind the scenes is that the search engine is trying to match what I've entered to a set of standardized terms in order to make suggestions for me. You don't have to choose one of the suggested terms to do a search, but doing so can improve the relevancy of the results coming back. So you can see here I've got a number of suggestions here for science keywords, projects, instrument names that all match up to the word snow. So for the purposes of this demo, I'm going to stick with just my term and ignore those suggestions for now. And next, I'm going to enter in a date range. Since I'm only interested in data spanning, let's just stick to the last 5 years. So to do that, you select the calendar icon just below the search box. And then click on the start date first and select your date range. So I'm going to go back 5 years, January, today's the 24th. And then my end date, I'm just going to do a shortcut here and say today. And then I'm going to hit apply. And the list of matching collections here in the center panel is updated. And now we're down to just under 300 matching collections to the search term and to this temporal range I've entered in. All right, so we're good. We're making some progress here. Next, I'm going to enter my geographical area of interest. And there are a couple different ways you can do this, but the quickest way is to draw an area of interest on the map. I'm going to do that, you select the map tool just underneath the search box up here. I select that. And then I'm going to select which shape I want to draw on my map. There's a few choices here: polygon, rectangle, point, and circle. I'm going to choose polygon. And once I make that selection, my mouse is actually turned into a selection tool. So you notice as I've moved over to the map area, it's telling me that I can click to start drawing my shape. Well, first I want to get over to my area of interest. So I'm actually going to pan over to the US. Let me get this out of the way here. And then I'm going to zoom in, get a better look at this area of interest. I'm going to zoom in a little bit more. Okay, this is good. Yeah, there's Colorado. And so now I'm going to draw my polygon. So to start that, again, you just click anywhere on the map to start drawing your shape. So let's start here, click. And then I just draw my polygon around my area of interest, a very roughly drawn polygon. And then once I close the polygon, you're going to see that the matching results are going to get updated. And looks like it brought it down just a little bit closer to 250, a matching collection. So that's good, but let's see if we can, I want to see if I can like narrow this list down even more. But before we do that, I also want to point out that you can, if you want to, for more precise spatial search, you can actually upload a shape file containing multiple points or multiple shapes. And Earthdata Search will actually draw the spatial region on the map for you. I'm not going to demo this today. I don't think I have time, but I wanted to mention it as another option for doing a spatial search. You can upload a shape file by going back over to the map tool icon, and you can see there's an option for file here. And then the modal will pop up and guide you through the upload process. You can also actually just drag and drop the shape file onto the map, and it will draw it on the map for you. Okay, so I've entered in my search term, my date range, and my spatial area of interest. And I've got this list of matching results down from, I think we started, I forgot to make a note of this when we started, but I think we were somewhere north of 12,000 collections when we started, or we landed on the page. Now we're down to about 250. And that's good, but that's still a lot to have to wade through, right? To determine if any of them are suitable for my needs. So we're going to see if we can narrow that list down just a little bit more with a few other options. So looking back over at the search panel, we see a list of filters, and these filters actually represent features that the data may have. For example, if you happen to know the satellite or instrument name, the satellite or instrument your data was collected with, you can choose to filter by that name by expanding the list. So let's just do instruments here. We click on this to expand the list, and we see a bunch of sensor names that are displayed and the number of collections that are associated with that particular sensor. So I can select one of these, and my collections, or the results, come back narrowed down. Look, now we're down to about 83. So that's one way that we can filter this list even further. A few other options I'll point out are science keywords. And then in the platforms, you can filter by organization, project, different processing levels, tiling systems, or the default data format that the data is made available in. And up at the top here, there's some highlighted features. You can also filter your results by data that's available in Earthdata Cloud. You can filter your results by data that are customizable. They have services that allow you to subset or transform the data before you download them. And you can also filter the results by which collections have sample map imagery associated with them, which can then be viewed on the map. So for the purposes of my demo, I'm going to select map imagery. Results are going to update, and now look, we're down to 62 matching collections. So that's a much more manageable list to wade through. Okay, so now let's take a look at the information that we get back from the application for each collection that's going to help us determine if any of these data sets meet our needs. So the first thing I want to talk about is how the search results in this results panel are sorted. The default sort is based on usage. So the most popular data sets matching your search criteria will be listed first. If you'd prefer to view the results based on search relevancy, you can do that. If you go over to the hover over the sort option here at the top and select relevance, it'll update the results panel, and now the matching data sets are ordered by how closely they match your search criteria. I'm going to go back over here to usage because I'm interested in the most popular data. All right, so for each collection or data set, we get a high-level indication of what the data set is and some of the features it supports on this first page. We can see the title that's listed here, the number of individual data files or granules that are associated with the collection, and the full temporal range of the data. You'll also see a set of badges here, and these badges tell us if an individual collection supports some more advanced features. So some of those advanced features could be advanced map visualizations. So this is the map icon. So I know that this collection supports these type of visualizations. And then over to the right, these are customization badges. And this tells us the types of advanced services that are available for the collection, such as spatial and variable subsetting, data transformation, and output reformatting. So we'll talk a little bit more about these options a little further in our process. I'm gonna keep moving on here. Another badge I want to point out is the Earthdata Cloud badge. When you see this badge, it means that this particular collection is available in EOSDIS's AWS cloud instance. All right. If I hover over this particular collection, you'll see that there's a little eye icon that pops up. When I select that, it takes me to a page that provides some additional information about the collection, including DOI information, native format of the data, any reformatting options that are available. I can see the spatial resolution for, the bounding rectangle for that data, a short description, excuse me, and the data centers that manage this data. To view a full set of descriptive information about a particular collection, you can click this View More Info button at the top. And that's going to take me to a new page that includes all of the information previously viewed in Earthdata Search, plus some information about any related services or tools associated with the data. Also, citation information is listed here, and also you can get links to any sort of related documentation that may be available, like how-tos or FAQs. That's all found on this page. All right, so let's go back over to the search results. Go back here. So let's say that based on the information in those descriptions that we looked at, we evaluated some of these collections by reading through the descriptions. I've got an idea now about which ones I want to take a closer look at. So let's say we're going to take a look at, let's just take a look at this first MODIS collection here. It's MODIS Terra snow cover data. I'm going to select that collection, and it's going to take me to a list of data files, which are also referred to as granules, that are associated with the collection. Couple other things I want to point out on this page. So on the left-hand panel, you'll see that this has been updated to display some granule filters, new granule filters. And then on the map, it's been updated to display data footprints, which are these, let me zoom out here for just a second, you can see this better. A little bit more. All right, so we see the data footprints, or the footprints of the data that are outlined here in green. And we also see some sample imagery has been drawn on the map. So this collection that I selected had some sample imagery associated with it, and so we're seeing that on the map as well. So all of this information here, it's here to help us evaluate the list of data files and pare down that list of files to just the ones that we're interested in. So the granule filters over here on the left allow me to restrict the list of files by features such as granule ID, if you happen to know it, the type of tiling system used, let's see, orbit number, equatorial crossing longitude, or crossing date. And for now, I'm just going to leave these as is and not add any additional filters here. Hovering over or clicking on an individual granule file in the center panel is going to highlight their footprint over on the map. So you see that as I move here, it's highlighting different footprints on the map. Excuse me. And this really allows me to see how these individual files overlap with my data of interest. So you can see, I'm going to zoom in again, see the polygon that I drew, and I can see how each of these data files overlaps with that area of interest. And the sample imagery really just gives me an approximation of what the data is contained inside the collection. Right now, at the bottom of the page, there's a timeline. And this timeline is showing me a visual representation of the temporal range of the data and how that overlaps with my selected date range. So I can pan through this timeline. I can just hover over it and grab it and move it left and right. So I can pan this timeline. I can also zoom in or out. So this defaults to the month. I can go by, look at this by year, or actually zoom in a little closer and look at the data by date. So let's move up here. I want to show one more thing. So if you notice here, and I hope you're able to see this on your screen, but you can see this this fence post here at the start date and the end date that this is the start and end date that I selected in my temporal search. And you can see how that overlaps with the temporal range of the data set. So if I wanted to update or change the temporal range that I already selected, I can actually do that on the timeline. If you hover here, you can select the fence post and drag it, move it left and right to update that temporal range that you've selected. So sometimes it's a little easier to manipulate this than it is to go back up in here and enter days, times, and hours. All right. Okay, so we've evaluated some of these data sets by reviewing the associated descriptive information and the sample imagery on the map, and have decided which data sets we want to download. So if I want to download all of the files in this collection, I can do that by clicking the download button, the download all button at the bottom of the panel, and the application will guide me through the download process. If I only want to download 1 or 2 files in this collection, I can do that by clicking on the green plus sign on each of the individual files. And once I select a file or a collection, they're added to my project. And projects allow us to add multiple data files or collections for download all at once. And we'll take a closer look at projects in a bit. So I'm going to select, let's see, I already selected these 3 files. Let's add this 4th file because these all overlap with my spatial area. And then I'm going to go back to the search results to add more data to my project. Now I can also add an entire collection to my project from this screen as well. When you hover over a particular collection, you'll see the green plus icon show up, and I can just select that and it gets added to my project as well. I can also go into another collection to add individual data files to my project if I want. So let's take a look at this one and add a few files here. Let's add this one and this one. Okay. So once I've added all of the data I need to my project, I can start the download process by clicking on the My Project button at the top right of the application. So I'm going to select that. And the project's going to load, and it's going to give me a preview of what I'm about to download. So let's walk through this page a little bit. The left-hand panel, I can see a couple things. So first I see the number of granule files that I've selected. Looks like I've got just about 5,500 granules in this across 3 different collections. And in total, it looks like it's about 47 gigabytes worth of data. Over on the map, I can see how each of the individual data sets I've added actually overlap with each other. Let me zoom out here and you can see it a little bit better. But now I can see how each of them overlap, not only with my area of interest, but with each other. Get this over here. And then down below, I can see how they overlap temporally in the timeline. And again here, or actually I'm just forget that, I'm not going to show that now. I'm also presented with some options for how I want to download the data. So there's in the center panel, I see there's 3 different choices here for me to make. And also I'll point out over here on the left-hand side, these little red exclamation points. This is alerting me that I need to make some decisions about how I want to download the data before I can actually start my download. So let's talk about these options a little bit. Most data sets are available for direct download, meaning I can download all of the data in the file like as is. Direct download is going to give me everything in that individual file. There are also some data sets that support services that allow you to subset and transform the data before you download it. And those are the customizations I was referencing earlier when we were looking at those badges in the results panel. So for the purposes of today's demo, we're going to configure each of these a little bit differently so you can see how each of these work. Let's say for this particular data set, let's select direct download. And then once selected, you can see that there are no other configuration options I need to select. So I can go over here, select, actually, no, sorry, I'm going to go back up here. This one, okay, direct download. I click next to go to the next one. And then for this data set, let's say I don't want to download the entire file because it's too big, or maybe I want to subset the data by a science parameter, and I also want to reformat the output format. I'm going to select Customize as my option, and then you'll see that a list of configurations have popped up at the bottom. So let's walk through these just a little bit. The first option I'm given here is to reformat the output file. So let's select that. So I want to reformat that one. I can also choose to subset this data file spatially by entering in some bounding coordinates. Then I'm going to scroll down here just for time's sake and talk about band subsetting. So you can also subset data by specific science parameters or bands. For example, if just say that this data set contained data on hundreds of parameters, but I was only interested in a handful of them, I can choose to filter out the parameters I don't want. So to view the different ones, you can just open the file and see which of the parameters are available. So let's just deselect some of these. And then I hit next. Once I've made all my selections, you'll see that now that the download data button here has become enabled, and I can start my download. So I'm going to start that download. And you'll notice here that there's this pop-up here that tells me that this particular data provider has some limits on the number of granules or data files that you can download it at the same time. So this is telling me that they have that my order has exceeded the 2,000 granule limit, and that they're going to split this order up for me in 3 different orders. Well, I'm okay with that, so I'm going to continue. But if you wanted to refine your search at this point, you can do that by just hitting refine your search. So I'm going to hit continue, and then the application is going to take me to the download status page, and where I'm going to get real-time status of each of these downloads. So let's see, the first one was the direct download method, and you can see that completed pretty much instantaneously. Those process pretty quickly. Once that's completed, I'll get a list of individual links here for to download each of the data files. So I just select a link, and then I can download that directly to my machine. If you're downloading a large number of files, we actually provide a download script to make that process easier. There's also a link to a how-to guide if this is something that you're not familiar with. And then if there's any browse imagery associated with this particular data set, those would be listed here as well. So let's scroll down to this one. This last one was the one that we customized. And you can see here that it's still processing this order. So I'll continue to get live updates of the status of this particular download, and you can see it's already starting to process the download. And once those files are ready, they'll be listed here in the same way that they were up here for the direct download. And if there are any, if the data sets include any additional resources or documentation like citation information or how-to guides, those would be listed here as well, but it doesn't look like the ones I selected have that, so that's why that's empty. So that's the whole process. That's the search, the preview, and the access. So you've got your data now, and you can go do science. Awesome. So that covers the most important features of Earthdata Search to help you find and access data. I think I've got a bit of extra time to show a few more features. Is that okay, Jennifer? I have like maybe 5 minutes?
Yes, that sounds wonderful. Absolutely.
Okay. All right, so let's go back to the main page. So just a couple of sort of bonus things I wanted to cover before we move over to the panel Q&A. So the first is a different way to search using Earthdata Search, and that's through portals. So what is a portal? A portal is a pre-filtered view of data in the application. And those pre-filtered views are usually by some sort of specific scientific topic or project. And you can find the different portals and navigate between them by selecting the Browse Portals button over here at the top of the search panel. That's going to pop up a modal, and I see a list of all of the available portals at the site. If I want more information about this particular organization or project, I can click more info, and that'll take me outside of Earthdata Search to this particular project's information page. But to view the data sets in the portal, I just select the portal card, and let's just do the Antarctic Master Directory. It takes me back to the main site, and this results list has been pre-filtered with collections that match or that belong to this portal. You can filter the available, you can filter all the data sets using the same set of features that we did in our original search here. And then if you wanted to leave a portal to go back to the main view, you select Leave Portal here below the portal name. The next feature I wanted to show or just highlight are subscriptions. So Earthdata Search offers users the ability to subscribe to receive notifications when new data is available that matches a particular search criteria that you've entered. So let's go back to what I did before. Let's just do, let's do iStep. This is pretty simple. So I've got this search criteria here entered in. At the bottom of the search panel, you see this subscriptions button. So I select subscriptions, and it's taken me to this new panel where I can choose to subscribe to this particular set of search criteria. Whatever filters have been applied or search criteria that I've entered would be listed here. And all I need to do is actually give this a name. So we'll just put create subscription, and I've got a subscription created. And so now whenever there's new data that's added to new data available that meets that criteria, I'm going to receive an email with direct links to each of those collections. And I think that subscription service runs once an hour. So whenever there's new data available, you'll get that. The next thing I want to point out are some user preferences settings. So when you go up to your name here, there's a pull down menu. This first option is preferences. And this allows you to change the default settings of the app, a few of the default settings of the application to sort of customize your experience with the app. I'll point out a couple. So the collection sort, I mentioned this earlier in the demo, how the site defaults to sort your collection results or your search results by usage. If you wanted to change the default to relevance, you could do that here. There is also the ability to change the panel state of the main panel. So let's go back over here. You'll notice that when you first arrive at the site, the results panel takes up quite a bit of real estate. If you didn't want that, if you wanted to maximize the real estate of the map, you can actually drag this and collapse it completely if you wanted. So if you wanted to have this be your default view whenever you go to the application. You can change that setting in user preferences. The last thing I want to point out is the notification bell up here in the top hat region of the application. This bell icon alerts you to notifications about things like system maintenance, outages, or actually important information about the availability of some data sets. So you can see here there's some active notifications. There's one here about data collections at NSIDC, NOAA, Sentinel-2 data. So this is pretty helpful. Pay attention to that notification bell if you see a red icon there. There's some information here about data sets. Okay, so that concludes the demo. I hope I've sufficiently lowered the barrier to entry for everyone looking to take advantage of what Earthdata Search has to offer. We welcome your feedback on what you think the tool does and doesn't do well. So if you have suggestions or requests for new features, or you just have questions for us, you can send those to us directly through the feedback button. Go away, little bell. So here's the feedback button right up next to the notification bell. I select that, and there's a form I can fill out. And these questions and suggestions come straight to our team. And now it's time for the Q&A.
Okay, thank you so much, Alicia. What I'm going to do first is actually open up our final optional poll, and then we'll get started with the Q&A. All right, here, you should be able to see that in just a moment. All right, can everybody see the poll? Awesome. Okay, why don't we go ahead and get started here? There are actually a couple of questions in the chat. So let me just do a quick scan if you don't mind, and then we'll hop straight down to the Q&A. I'm just taking a quick look. Thank you for your patience. Okay, so I think, one of the questions, and I don't know if you want to share your screen again, was to show how to reformat the data file when attempting to download. And my response was that not all of the data sets in Earthdata Search will have that option for reformatting, but certainly there are, where that might be desirable or required, there are other tools that can perform that same task, discipline-specific tools. I don't know if you want to go back over that or really quickly, or
Yeah, I mean
should you?
yeah, I mean that's correct. One that I did use where I did I customized the output. I made that selection. So that's basically that's how you do it in the customization options for a particular set of files. If that service is available to reformat the output, it'll surface that information there. I can actually go back to and show that if that would be helpful. But that was the example.
Sure. If you'd like to share your screen again for a moment, that would be fine.
It'll take me a second to get back over to that. So maybe we can move on to the
That's
next
okay. Yeah,
question.
let me go ahead and do that. So the next question is it possible to download an array or time series grid using Earthdata Search?
I will chime in as not a data scientist. This is Valerie. If an array or time series grid is in fact the data file that has been has a metadata record in Earthdata Search or in CMR that Earthdata Search can find, then that's the data set that you will download. They aren't the majority of our data sets, but we do have them, and you should be able to get them as well.
Okay, thank you, Valerie. And again, that's another example where perhaps that's not a capability available through Earthdata Search for many of the products, but it is something that you could reach out to that individual data center for additional information. So the next question is, can the map be changed to polar projection?
Yes, it can. And I can show you how to do that. Let me share my screen.
All right, excellent. Thank you, Alicia.
All right. Let me collapse this for back to home. All right, so this is the default view when you arrive at the site of the map, but you'll notice there's some, and I didn't point these out, but over here on the right-hand side of the map, there are some different selection options. The first one is polar projection. So if I want to look at the North Pole, I can select the North pole icon, and it takes me to that projection view, and also the South Pole, like that. And then to get back to default, you hit the center.
Alicia, could you also, just to go touch back on the grid, for example, the data format facets, grid is an option there. So, I mean, it depends on what the data set is. And actually, I do have an answer for David as well. We want to jump ahead.
While I'm here, let me show you how you can change the output format during the download process. So this is the same collection I was looking at earlier. I select the customize option here, and then down below, if reformatting was supported for this particular collection, it would be listed here, and you can see that I can reformat this into GeoTIFF if I wish, if I want to, and then that gets processed when you download the file.
Okay, thank you. The next question is it possible to download information outside the USA, such as South America? And Valerie, you can.
Yes, conditionally, yes. So NASA is a member of the Committee on Earth Observation Satellites, CEOS, which is a bunch of different international Earth science agencies. And part of our contributions for that partnership was actually providing the IDN search portal, which is an Earthdata Search portal, and the backing of CMR. So we have metadata collection records from a slew of different international data providers. However, whether or not you can download the data files for those collections is dependent on whether or not those providers have configured.
Valerie, I don't know if it's just me, but your audio is broken up.
Oh, dang it! I'm even using my headset.
Is anybody else experiencing that? Can you type into the chat if you can understand what Valerie is saying?
Yeah, no, I was hearing her clearly.
You were able to? You can hear perfectly?
Yeah.
Okay, maybe that's on my end. Yikes.
Okay, I'll try to project as well. So if the international data provider has a properly configured open search description document in their metadata record, then their data files, the granules will be discoverable and downloadable through Earthdata Search. Not all of our international providers have those OSDDs configured though. Some of them do. and those are great. That's, fully federated search and discovery across agencies and internationals. But not everyone does. So that also, unfortunately, depends on the data set.
Okay, thank you. So let's see here. The next question is, I'm hoping that was just a temporary glitch. I was going to put the CEOS IDN link into the chat, or Val, if you would like to do that, that would be great. Can everyone hear me okay? Is my audio fine?
I can hear you.
Great.
Loud and clear.
Okay, so let's see here. All right, I'm going to skip down to the Q&A. I'm just hopping back up to the top just to make sure. Okay, so I'm going to go to this question that was asked just a moment ago. Thanks for the preview so far. I am thinking in terms of how easy it is to label or get labels, for example, fire risk based on some data, or to connect different data sets for training and in some an ensemble machine learning model for fire risk prediction or to get labels for data A from another data source B. Is there a way to search commonly used together data sets? Furthermore, and there's actually quite a few pieces to this. Furthermore, are there data sets that provide labels from analysis being done with them? And is there a way to filter these?
Goodness, there's a lot there. Some of that we might be better following up offline, but was there a question in there about how to identify data that utilizes AI? Was that sort of part of the question? If yes, there right now we don't have any way of surfacing that data in the application.
Okay, thank you. Unfortunately, I'm still hearing that feedback when Valerie is speaking, but I'm glad to hear that nobody else is. Okay, so the next.
I'm muted.
Okay.
Still hear me when I'm muted?
That actually sounds much better right now. Okay, so the next, let me see if there's anything else that I've missed here. I don't think so. Taking a look through. One of the questions earlier on, and I don't think that Earthdata Search is the right tool for this, for visualizing like real time. The question was, can we use Earthdata Search to track real time reforestation or deforestation? And my response is that to visualize something like that, a better tool might be to use NASA's Worldview imagery mapping and visualization tool to kind of, compare imagery over time. And also you can check out LANS for near real-time data sets. But if anyone has anything additional to add to that, please let me know. Looking to see if there are any additional questions. I did see something in the chat. Hold on one second. Yes, is there a limit to the volume of information that can be downloaded?
In some cases, a data provider will limit the number of files you can download at any given time, but that is data provider specific. And
there's an actual max of, I think it's 1 million.
Okay.
Thank you, Ryan. And thank you, Alicia.
And as demonstrated, Earthdata Search will chunk larger orders into, chunks and individual orders instead of all one big thing.
Thanks so much, Val. Okay, looking to see. I don't see that there are any additional questions. Just looking back through. If there are any additional questions, please feel free to enter those into the chat or the Q&A. And if not, just as a reminder, the webinar has been recorded today and will be uploaded both to the Learn section and the topic webinars and tutorials on the Earthdata website, which is earthdata.nasa.gov, as well as to our Earthdata YouTube channel, which is, you could just go to YouTube and type in NASA Earthdata. Okay, so I do have another question that just came in. So the question is, how does the data in Earthdata compare with Earth Explorer?
I'm not, I don't, go ahead, Val.
I was going to say, I'm not familiar with the data in Earth Explorer enough to say.
So I do have a little bit of information about, so Earth Explorer, you are pulling quite a few USGS data sets, so some of your Landsat data, and also quite a few land processes, NASA land processes DAC data sets. So I think it's a more discipline-specific focus within Earth Explorer, whereas within Earthdata Search, you are able to pull data from all 12 of our, NASA data centers and also from partner agencies as well. So hopefully that answers the question.
Okay, and I saw Nick's comment that this is a LARC tool. So we do house LARC and LP data sets in CMR in Earthdata Search. quite likely what you'll see in their tooling is more of a portal-esque focus on just their holdings. I can't speak too much more in depth without knowing their tool better. But it should be in Earthdata Search as well if it is from those providers, the LPDAC and LARC. We also house that data as well.
Yeah, so the question I read was not about the Data Explorer, it was about the Earth Explorer tool, which is definitely something out at USGS. So maybe someone asked a question I may have missed. Okay, so let's see, looking down. I don't see any other questions at this point. If there are no further questions, what we'll do is we'll log off from the audio component. I will leave the virtual meeting space open. So if you are interested in filling out the, no, that's okay, Nick. If you're interested in filling out the optional polling questions, we really do appreciate your feedback. That really helps to identify topics for future webinars and also, you know, can provide insight on data user needs. So we really appreciate your feedback there. Thank you so much. Let's see here. I'm looking. If you think of something, feel free to type that into the chat or into the Q&A after we log off from the audio, and I will forward that information along to our speaker and our Q&A panelists. All right, well, I think that's it. I'm not, oh, excuse me. I do see one more question. My apologies. Okay, so could you give me some hint of how to use Earth data from QGIS? That I'm not sure if I understand this correctly, but if you are, and maybe you're talking about a linkage between Earthdata Search and QGIS. I mean, certainly our data products can be used in QGIS, and there are a number of data set and discipline specific tutorials out there that might be helpful. But if I don't have the focus of your question right, could you add a clarification here? Or if any of our Q&A panelists wanted to add something, please feel free to chime in.
I'm not entirely sure about the QGIS question either, but I do see a comment from Fotini above that, talking about associated data sets. Did we address that and I missed it?
Let me close the chat panel. No, yes, we did actually address this question.
Okay.
Yes.
Yeah, I just wanted to.
That's okay. No.
And in,
No,
yeah, in
it's
case we didn't demonstrate the associated data sets and the ways in which we can associate them.
So Fotini, do you feel like your question was answered? I think I read this a little bit ago. And if not, certainly we could go over it again. We have some more time in the Q&A session. Yes. Okay. So the participant would like, would like additional information. If you could cover that again here.
So in the demo, when we find a collection and you look into it, there are several ways in which we can find more information about a data collection. And we do have several ways in which we can associate different data collections to one another and other different concepts to one another too. They can either be done through science keywords. In the metadata, they can be done with CMR tags if we want to identify, you know, associated projects for like a search portal. You know, we have some search portals that are, you know, project or campaign specific, and so those are related data sets. You can find in a limited area. There's also the, thank you for the the shared screen, the you may also be interested in, you know, related data sets and related URLs. If it exists in the metadata in terms of, you know, these related DOIs, then we can surface it here. You can see related collections here. Predominantly, for the related collections, we have data sets that have been cited in the same documentation URL with one another. So they've been used together in a study, and so you can find the recommendations that way. But there are several other ways to denote a related data set and discover them through Earthdata Search.
Thanks so much, Val. All right, I think at this point, if there are no additional questions, I'd like to thank our speaker today, Alicia, and also to thank Ryan, Valerie, and Joe for being Q&A panelists during this afternoon session. We'll log off from the audio component, and I'll leave the virtual meeting space open in another 15 minutes or so. So if you think of something, feel free to add that into the Q&A. I will share that information with our speakers, and our panelists, and they'll be able to follow up with you offline. The recording will likely not be ready until Friday, although I will try to have it ready tomorrow. And if so, I'll send an email out to all of you, all of our participants, and also registrants who perhaps colleagues who were unable to attend today. That'll include the presentation slide deck link and the recording. So thanks so much to all of you, and have a good morning, afternoon, or evening. We appreciate you.
Thank you very much.
All right, take care, everybody. Okay, goodbye now.